Hi, I'm Shannon Egan, and this is my final project for CS50P named ImageAlter. ImageAlter is a command line operated toy for transforming bitmap images into different vector mapped shapes, such as circles, arrows, and squiggly lines. It does this by first pixelating an input image to a manageable degree, then using each of those now large pixels to map a location and color value to a vector image, using Pillow to interpret the image and Cairo to create a new vector. ImageAlter uses argparse for convenience of use, and the help message can be seen here. The original picture file name is a required positional argument, but the output file name is simply output by default. The next most critical optional argument is M for mode, which specifies the type of transformation that will be applied to the image. If it's left blank, the output will be a PNG file that has been pixelated to a degree specified by the R argument. Here we have a photo of the dog Olive before modification. So then we're going to run the following command: Python imagealter.py, specifying the directory as dogs/olive.jpg, which is the file name, and the optional argument R30, which is the amount to reduce a block of pixels by. We run this to get the following output, which is a now heavily pixelated version of the same picture as earlier. This mode is referred to as pixelize, and it only really exists to enable the further modes, so they can operate over a square block of pixels rather than every single pixel in a single image. Now for the first real mode we'll demonstrate, we'll use this picture of the dog Chewy, shown here. We'll use the code shown here. We use Python imagealter.py with the directory dogs/chewy.jpg as the file name. This time we're using an optional argument O to specify an output file name, which is just going to be example. The extension in this case .svg will be added to the file automatically. We're going to specify our mode using the command M, and we're going to specify circles. We run this and get the following output. So now we find Chewy as a collection of vector circles, each one with color and position reflected by the original bitmap image that had been previously been pixelated by the pixelize function. Our next mode to demonstrate will be stars, using Rex here. It's ran in a very similar way to before, except we're now using the mode stars instead of circles. We're also going to specify a background, which is ordinarily transparent. In this case, we kind of want a black background. It just works better in my experience. So it's a background of 0. We run this, overwrite the previous file, and we get the following output. And predictably enough, we get an image of Rex, except now he's been converted to small stars instead of circles, like the previous mode. The one gimmick with stars, though, is that we can introduce a spin angle to these. This only works in this particular mode, and it will introduce a spin of 15 degrees, or whatever degrees is specified after the SA argument, to every sequential star in a row and every sequential star in a column. We output this again, we'll overwrite the previous file, and we get the following. So this has introduced a small sort of rotation to all the stars as they progress further along the image, which causes them, because it's slightly asynchronous, to have a sort of interference style effect by nearing each other at different stages. For our last mode here, we're going to use Olive on this hill with a nice view in the background. And we're going to run the dodgy mode, as shown here, with the following command: Python imagealter.py dogs/olive_view.jpg. Currently, we leave the output the same as example, and we're specifying our mode now as dotty. We're specifying a different R argument in this case, just because I know it works better. Keep this precise. Run this again, overwrite. This can take a little bit of time to convert, depending on the R setting, and we'll receive the following output, shown here. So Olive is now replaced with a series of circles, similar to before, except the color has been averaged and used to specify the radius of the dot. So in this case, up here, where the sky was relatively light, we have very small radius circles, and down towards where Olive is, the circles are so large they actually overlap. So we're kind of inferring the image from the density of the dots, in effect. So that should wrap things up. There are 2 additional modes already incorporated: arrows and squiggles. Arrows on the right, squiggles on the left. I've tried to structure the code in such a way that additional modes can easily be added and designed into it, so that we can specify them simply and just incorporate them directly into this system. That's the entire presentation. My name's Shannon Egan. Thanks for watching, and thanks to CS50P and all involved staff for the course. Thanks very much.